want to talk to you about rotary tables. I'm going to use one on my next project that I'm in the process of working on, and it's this right here. This is a bowl made out of cherry. I've got one coat of finish on it, and I've turned it with a thin ring, as you can see here, and that's going to get a particular carving done on it. And here's an outline of the carving. You can see that it's kind of geometric in detail. The one of these has been blackened to really show the area that's going to be removed. So you can see I'm going to have these slots and this arc carved away. And that's going to be done using a high-speed die grinder with a carbide burr in it. Trying to do something like this by hand alone is pretty much impossible. You're trying to cut straight lines and very precise arcs in wood with different grain structures. So what I found is that if you use a rotary table in conjunction, in fact, with a slide table, which I'll show you shortly, you can get those kinds of things done very nicely. A rotary table is, as the name implies, a table that rotates, but it does so very precisely, very accurately, and very rigidly. Now, typically machinists use these on mills and such to do precise spacing of holes, things like that. You can also leave the tool engaged and rotate it, which is how I'm going to use it. These are fairly heavy. This one's probably about 40 pounds or so, maybe a little more. This one also allows you to tip it up, as you can see there, which would be handy. You can imagine if you have a bowl out here, you can do side work on it. Or laid down, is the way I'm going to use it next. Now, as you can see, I'm going to cut these arcs. And these arcs are very well suited to using a rotary table. However, these straight lines, the table only rotates. So what I'll do is put the table on top of a cross slide table, which is this. This guy allows you, as you can see, to move linear dimensions one way or the other way. It'll also rotate, traverse this way too. So if I have the rotary table mounted on the cross slide, then I have rotation and linear motion available to me. How you set it up, of course, determines what you're going to end up with. And so as you can see here, I've laid this out such that I have 0 degrees, and then as it turns out, this line here, to give me the spacing that I want, comes out at 3 degrees, then 57, that's cutting the arc, then the next jump to 63, and on around. You do want to lay something like this out first before you start, otherwise you'll get totally confused. And I've learned that from experience. So, once you have the rotary table, and you have something like this, you can see you have T-slots in here for mounting, but this doesn't really conveniently adapt to that. So what I've done is I've created a little adapter plate. This here is turned out of just yellow pine that I had laying around. It will fit on the rotary table, and then this will fit nicely into the adapter plate. These screws here just jam in there and hold it in place. And you can see that you do have to be careful when you do something like this so that the screw, if you use this method, doesn't hit any place and allows you to get 360 degrees of rotation. You can also make an adapter plate like this, which would engage these T-slots so that they would be hidden here. So again, it's how you do it. Doesn't matter all that much. It's just that you maintain the concentricity to the table with your piece. Another way to use these, this one here has a Morse taper hole in it, which is a Morse taper number 3. And of course, everything I have is number 2, so I just got an adapter sleeve. Go to any tool shop and get these. And that would go in here. If you have small pieces, you can use your scroll chuck from your lathe and position it any place you want. That's about what I wanted to show you. The next thing I'm going to do is build all this up on my drill press with my high-speed die grinder and we'll go ahead and cut some of these details on there, and you'll see how that all works. That'll probably be in another video, because I got a little work to do before I get to that point. Thank you for watching.